This winter I decided to spruce up the balcony a little bit by using one of these battery operated string lights. Now, instead of using the batteries you're supposed to use in this, which are two C-type batteries, normal single-use batteries, I thought we would make it a little bit more complicated by using one of these things over here. But I think first off we'll remove this again and then we'll have a look at what's actually inside of here. So this is what we find inside. We find this happy little bundle of LED lights. I think it was supposed to be 120 of those roughly, which might be true. And then we also find this little box here, which supposedly has these two, or is supposed to have these two C-type batteries. There you go, two of them in there. And then also a push button in here that you can actually get to from out here as well. Having a close look at this magic box of tricks here, we can see our two battery compartments here for two C-type batteries. And then in here we seem to have some sort of electronics. This would be where your timer is and stuff like that. And then we also have this quite nice rubber type seal around here. Can't seem to get that off, but when we close this lid it makes a nice kind of tight seal around there. So this looks actually pretty good. I'm kind of happily surprised by this. It looks like this is going to be not too bad to do the kind of modification I'm looking for doing here. And that modification would be to get this power bank to power these lights down here. Now, this power bank I found in the trash. You can see these 4 charge level indicators and then a button over here. I believe why this thing was thrown out was because this USB connector here, you can see it's kind of loose. We could quite easily fix that, but we'll see if we actually make use of that. But that's probably why this thing was thrown out in the first place. The cells themselves seem to be just fine. I haven't really tested the capacity much, but they seem to hold a charge well and things like that. So they should be just fine for powering this LED string light on there. Now, one tricky part about using these lithium cells instead of using the batteries this thing was designed for is that these two batteries would have a nominal voltage of about 1.5 volts each. And since these are hooked up in series, that would give us about 3 volts. Now, the lithium cells typically have a nominal voltage of 3.7 volts. And fully charged they would be up around 4.2, so that's definitely a lot higher than this thing was really designed for. But to figure out if this is really going to work easily or not, I think I'm going to try to open this part up and have a look at the circuitry in here and see how this has been designed. We might be able to get away with running it at a higher voltage anyway, but we'll find out once we get this thing open. With the cover off, we have a little circuit board in here. I'll get this thing out and we'll have a closer look at it. And now we are ready to test this thing out. So the setup here is 12 volts coming in, going into one of these little kind of breadboard power supplies set to 3.3 volts, which is fairly close to the 3 volts you would get from these batteries. This one is then hooked up to normally where the battery would go. And then we also have the LEDs still hooked up. So to start off with, I've already tried this, so I know that it works. So if you plug it in, it lights up nice and bright. Looks pretty good. So I thought we would have a look at the current draw here. So the meter is set to milliamp scale. So if we hook this thing up, you see that it turns on. And we get about 35 milliamps DC, which I don't know what I was expecting really. I think that sounds pretty reasonable. So now we know how much current it draws there, 35, pretty much spot on, not really moving at all. Okay, so now comes the question then, can we run this on the 5 volts from the power bank, or can we just run it straight off the lithium batteries? Now, I'm not really sure. Since the chip on here doesn't really have any marking, well, it doesn't have any markings at all, I can't really look up what kind of operating voltage it can work under. So I think I'm just going to try it, honestly. This thing can go up to 5 volts, so I think I'm going to switch it over to we're gonna set this up for 5 volts now, like that. There we go. So now we have 5 volts across here, and I'm just gonna use, just to avoid this thing like completely frying in case it's not really made for this, I'm gonna set this meter in battery test mode, which basically it functions as a voltmeter, but it has a low input impedance, so it'll actually put a load on the battery is normally how it's used, but I'll just use it as a kind of I guess smoke stopper, if you're familiar with that that way of calling it. So basically just putting a resistance in series with your load to make sure it doesn't completely catch fire. But now we're set to 5 volts. Let's just connect it here and we'll try and see if this thing lights up as usual. And look at that, it actually does. So we're dropping about 600 millivolts across the meter now. So if this thing is outputting about 5 volts, that would give us about 4.4 volts. So that's good to know. It can take 4.4 at least. But I think we're just going to try and hook this thing up straight up to here now and see if it can run at 5 volts. And it does seem to run at 5 volts, so that's good. We'll just unhook it again and we'll try to measure the current this time. Okay, same procedure, milliamp scale. And this time we're getting 56 milliamps. So that's quite a bit higher actually. I'm not sure if the LEDs are any brighter. They might be actually. Not sure, but this thing doesn't seem to be burning up immediately at least, so that's a good sign. It is now the second day of this project, and I've made quite a bit of progress to the point where this project is pretty much done. There's only the finishing touches left, so I thought we would go through this setup as it is now, and just to give you sort of an overview of what actually ended up happening here. Essentially, this thing is now made up of 2 different products. So we have the Powerbank side over here, and then the part that was in here initially, which is the light electronics over here. So we'll start off with just the Powerbank side here. So not too much has changed here. We have the 2 cells underneath here and the electronics that accommodated the Powerbank initially. So the cells are hooked up to this side here and side over here, negative and positive. And the cells are hooked up in parallel, so maximum of 4.2 and maybe minimum of around 3 volts is going to come in through here. And then, since this normally has a 5 volt USB output, we have this inductor and this little chip here that makes up a boost converter. But in this case, I'm not actually using that, and there are a few reasons for that. The main one is that this board over here doesn't really, well, it's not really designed for 5 volts. We've seen before that this thing can take 5 volts in, but if I don't have to use the boost converter here, I'm not going to use it, since it just leaves us with more losses and we really don't need it, so I'm not going to use it. So we can see that we have a wire hooked up over here, which goes over to positive side of the light electronics here. And then we also have a ground going from where the USB type A connector was, which is what you would use to charge your phone, for example, hooked up to the ground here and then going over to the ground here. And then this is the micro USB connector for charging the power bank itself. And you might think that this, initially I wasn't sure if I could really do it this way, because I wasn't sure if the microcontroller here was doing the shutdown when the cells would get too low, because I still want to make sure this thing shuts down if the voltage drops too low and we're starting to discharge the lithium cells too far. I really wanted to turn off in that case, because I probably won't be babysitting this thing too much once it's up and running. But what I found out was that this little chip over here, hiding in the corner, seems to be a lithium ion protection chip. I can't really, I looked up the numbers on here, I'm not sure what it says right now, but I couldn't find anything. But from a little bit of testing, it seems like this chip here turns off the ground connection here. So this connection here to the ground of the battery here will be cut if the voltage goes too low, or probably too high as well, from what I can see. But I'll be testing that out once this light is up and running. I'll be keeping an eye on it. for the first few days, and I'll just not charge this to keep it in a kind of low state, which it is now. I think it's at like 3.6 volts now, so it should discharge very quickly, and I'll see if this actually works. Okay, I believe that's pretty much the power bank side. Not too crazy, we're not really using a lot of this. We're mostly just using the charge ability here, so this part is still here, and I can just plug this in with a regular micro USB cable, and it'll charge normally without really affecting anything else. Now let's move on to the actual lights part of things here. So this PCB is basically, I've just left it the way it was initially. This is where the other batteries would be hooked up, so positive, negative. And then this consists of also a step up or boost converter. So we have an inductor here, then a little switch over here, transistor MOSFET type thing, and then a little diode over here. So basically the same setup over here, it's just that this one is more integrated into this chip, so this thing has a diode and all that built in. This one has it as discrete components instead. And it seems like this, there's no markings on this chip. I suspect this is just a small microcontroller, I'm not really sure. But it does have this sort of crystal or oscillator type thing, probably to keep track of time, since this thing has a timer feature where it'll stay on for 8 hours and then off for 16 and keep doing that, which is quite neat. I'll probably be using that feature actually. So basically we get this voltage in, it's stepped up to whatever the LEDs use. It seems to be at about 24, I believe, something like that, to run these. And it's not really, like, this setup isn't great in the sense that it seems like we're running the LEDs harder than they were initially supposed to be. And that we found out earlier that the current actually increases, the current input here increases when we use a higher voltage here as the input, which is kind of weird. I would expect this thing to be current regulated and not just have like a fixed duty cycle, but that seems to be what it has. So maybe you can mess around with like some resistor network in here to bring it down so that it lowers the current through the LEDs, but it's not really that important. I haven't spent enough time to really figure out how that works in here. And then we just have this button in order to set if we want to run this thing in timer mode, or just have it be on all the time, or if we want to just turn it off basically. And these two connections here are what actually goes out to the LEDs. And then down in the corner here, which you can't see very well, it's just the cables going out. It's this one over here, goes out to the actual LEDs, and there's just some seems like a glue stick type glue down there, which seems pretty good. I do expect this thing to be pretty much watertight. I haven't tested it or anything, but I think that should be just fine, and I'll probably keep an eye on it the first day or so, but I think it's gonna be okay. We haven't really messed with that part at all, so should be pretty good. And indeed good it was. So I set this thing up outside for a few days, and I noticed after a few days that it had gone dark, it had turned off. So I brought it back inside and I measured the cells, and they were at 3.2 volts roughly, which was great. That was what I wanted. So it turns out that the mystery chip at the corner of the PCB was actually a lithium ion protection chip, so that was good. I've now charged it up, and it is now set up again, and it is making my balcony look sweet, so I'm really happy about that. One note I will say about this mod, if you're looking at doing something like this yourself, I believe that the setup that I have now actually has less capacity than the C-type cells that were supposed to be in there. So if you're looking for getting actual more capacity or more runtime out of this, I would not suggest this, or try to get some more cells in there. Maybe they get like 3 or even more in there if you want to do something like this. The pro of this setup, of course, is that I can recharge the power bank. I don't have to go and buy new batteries for it all the time. So that's a little summary for you there. I want to end by thanking you for watching this video, and I hope you at least found it informative. So it was probably, whoops,